A common phrase we probably all heard is that data is the new oil. As a result, more data is being captured, stored, analyzed to help make deterministic decisions now and into the future. This also means that more data is being duplicated and stored in different repositories to suit the different applications that need to use and glean information and insights from the data itself. It also means that it's hard to know what types of data and if sensitive or critical data elements have proliferated to all these different repositories. As an example, every time there's an ETL process, meaning extract, transform, or load process, or just a straight copy of files from one silo to another, it incurs duplicated or at least similar data. The first step to data minimization is to identify duplicated and similar data and determine what data should and can be minimized. This in itself can be a daunting task after literally years of data sprawl, which has exacerbated the scalability and coverage limitations of traditional tools to scan, discover, and classify data. Data privacy regulations increasingly emphasize that enterprises collect only what they need under the principle of data minimization, and every file that is redundant and or duplicated unnecessarily expands the scope of data that must be secured, especially if it is sensitive in nature. So that means enterprises such as yourselves need to be able to find duplicated data and or similar data at scale across different disparate data silos and across different databases to address these interlocking needs. Identify duplicated or near duplicate files containing sensitive and personal data at scale using machine learning across large volumes of unstructured data, whether on-premise or in the cloud. Right? We also have to automatically classify and apply labels to files containing similar attributes and common keywords, minimizing manual steps and enabling scale. Right? And we also have to think about reducing time to improve accuracy and identifying duplicated files and data copies that potentially violate minimization policies. Sometimes in order to do this, we have to apply retention policies to the original files themselves. Minimize the number of duplicate and near duplicate files to reduce storage overhead. So we have to identify low data and enable low operating costs and minimize on-prem footprint. And this is important too if you have like some migration strategy to the cloud. It's like, all right, what data can I migrate and why would I don't want to migrate duplicated data. There's no point in doing so because it just imposes more risk to my business. So the starting point for anything as it relates to data minimization is really data discovery, right? It's the first critical step to understanding your data, and from there, take the necessary action on it, whether to understand security concerns, compliance and regulatory issues, privacy, and or governance. BigID's Discovery in-depth looks at everything across your data landscape. On the left, we're talking about all your data, and this can be structured, unstructured, any data that's on premise or in the cloud across different data lakes such as Hadoop or applications like SAP, and for data at rest, whether it resides inside of some kind of an RDBMS or flat files, and or data in motion such as Kafka or Kinesis. BigID applies essentially different lenses to the data represented on the right in order to help organizations get the most value from what BigID discovers within these different data repositories. BigID catalogs the data. One view across your data silos, incorporating both metadata and data, regardless if it's structured, unstructured, one view in a catalog across each of these. BigID classifies the data leveraging NLP and machine learning for deeper classification and insights from your traditional approaches. BigID also applies cluster analysis to the data in order to find similar, duplicate, and or redundant data, which is critical to the data minimization use case. things such as cloud migrations, retention, and more. Finally, BigID is able to correlate the data, which is essentially the key to connecting similar data and understanding dark data. On top of this discovery foundation, BigID has an application framework that allows for different business-related perspectives on top of BigID's extensive discovery to be created either by us or by a community of members leveraging our APIs and or SDKs. These applications allow individuals to take the appropriate action on top of what BigID surfaced when scanning your data repositories. There are applications that cut across governance or perspective, privacy, protection, or security, utilities which help extend reach into other applications already in place within your organization. This dashboard gives me a high-level view of everything that BigID has scanned, essentially, and the findings of what it's been able to uncover within these disparate data sources that BigID has been configured with. Right, so we have a total of 29 different data sources. 18 of these data sources have something relevant that it's found across them. We have a total of 158,000 entities that have been created via a correlation learning set. We have essentially 32 different policies that have been created. 18 of them have found something. We have 95 different attributes that have been found across the different landscape of sources, right, and objects that have findings. Within this dashboard, we also have shortcuts to things that are commonly done, common tasks like connect a new data source, right? Maybe I want to import a data source. Maybe I just want to look at the results of a specific scan. Maybe I just want to jump straight to the catalog. And then we also are given a map that shows me identification of where individual residencies are located across the geo in this map here. I can have an understanding of how different applications are interacting with different data repositories. And each one of these are tabs across the top where I can look at risk over time, attributes over time, and policies over time, and the number of findings per policy that has been triggered, whether it's across, looking at CCPA or GDPR. And then I can just quickly jump over to the different insights, right? And for this specific demonstration, I'm going to hone in on data minimization. And a big part of data minimization is understanding across the data landscape, across these 29 different data repositories that BigID is scanning, where are my duplicated files, right? So I'm finding 3,213 duplicated files across the data landscape, right? And then you can get even more information. Maybe I want to do a DSAR request, right, across these data repositories. So from here, let's just quickly click on, all right, let's quickly leap over to how BigID has found 3,213 duplicate files, right? And this is going to bring us to one of the C's of the 4 C's inside of BigID's framework, the catalog. You also notice here that we have correlation, which helps identify like data across my data landscape with a definition of a correlation learning set, or a set of information that is important to your business for BigID to understand across my data landscape. Cluster analysis provides me a grouping of like files in the common keywords that have been found across the files, and it groups them into a cluster, right, for data similarity. We have classification. So when BigID scans your data, we are able to apply different classification techniques to that data to help me understand where I might have sensitive data. And the last one that we're looking at right now is the data catalog. So as I'm scanning all these different data repositories across your data landscape, let's show what we're finding inside of a single pane of glass data catalog that shows both unstructured and structured and or real-time data feeds, right? And you can see the different data sources here, right? I got SharePoint data sources, SMB, OneDrive, and this is just looking at some of the structured sources because I have this filter applied here from clicking the duplicates, the 3,213 objects that have been found to be duplicates, right? So by removing this filter, you'll see it clears this query. And now I can see, all right, I have data in motion. I have certainly other structured repositories such as Snowflake. Again, a single catalog for all my files or all my data repositories, whether they're structured, unstructured, data in motion, etc. So let's just toggle this back on to focus in on the data minimization use case of being able to identify duplicates, right? So you can see here that it looks like I have a number of files that have the same name. They don't have to have the same name. They can certainly be different names, but the context inside of them is showing or telling us that these files look to be duplicated across these different silos. And I can see that, honing on this one specific document that looks like it's a resume of some sort. It resides on SharePoint, but the same file also looks like it resides on a network file share, right? And I can get information about this, whether it has open access, meaning everyone full control, or whatever I've identified or imposed upon my system to have open access. Maybe it has more granular than everyone full control, as an example, right? But it shows you the duplicates. It shows me the attributes that have been found on top of the file, etc. So let's just go ahead and click on one of these files to give me more insight on the file itself. I can see the owner, and this provides me with the SID. If this was linked to something like Active Directory, it would automatically translate this S number to BigID /drice as an example, right? Full object name shows me the location of where this file exists. I get the size, I get the language, I got the timestamp, data sources, etc. associated with this specific file. And from here, I can get the labels that, all right, it looks like this thing has open access within this NFS share. It contains some kind of a sensitive information and has duplicate data because the file has been duplicated. It looks like 4 different times across different repositories. Clicking on attributes, I can get an understanding of how things were classified within this object when we scanned it. I can hone in on specifically like a date of birth, and I can actually say, let's look to see why BigID classified this file as having a date of birth. And by pulling this in, and it's important to note that myself logging into the system, my role-based access control as my user has permission to be able to visually see this. If individuals should not see this information, it would just be a role that you would toggle to say, hey, don't let people preview this specific data. But inside of here, you can see it looks like, yeah, here, sure enough, here's the birthday and why BigID classified this object to have a date of birth.